Hello, Math 1224. This is Dr. Patterson, and this is Lesson Launch 3.01, which I'm titling the Zen of u-Substitution. I'm calling it the Zen of u-Substitution because when you're integrating, substitution is a strategy, and it takes some skill and some instinct to know when and how to use it so that you're using it correctly and strategically. But when I say Zen, I mean there are some ideas that you can have or some instincts that will help you to use substitution correctly and strategically. Alright, so just as a reminder, we talked about in class the fact that if you have an integral, let's say you have an integral f of w of x, I'm changing my u to w now, just because of the notational mishap that happened in class, times w prime of x dx, then the antiderivative of that is going to be, that's not meant to be a z there. Handwriting on a tablet is challenging sometimes. There we go. The antiderivative of that is going to be big F of w of x plus c, where f is an antiderivative of little f. So that's the basic idea, and the reason for that, once again, is the chain rule. That's what we discussed in class last time. But if we're going to use substitution as a strategy, we're going to have to get good at identifying what is the right choice of w, what is the right choice of w prime, that of course is linked to w, we don't get to pick it, and what is the right choice of f. So here's an example. I'm going to zoom out. Alright, let's suppose that we want to take the integral of this function, 3x squared dx over x cubed plus 1. Let's suppose that we want to take the integral of that. Alright? Now, one thing that we notice here is that we have a complicated function, x cubed plus 1, in the denominator. Now I'm circling that and not circling the entire denominator for a reason. This is where the instinct comes in. So I have that x cubed plus 1 down there. Now the reason I circled that specifically is that I also noticed at the same time that I have the derivative of that function, 3x squared, in the numerator. It's like that's being multiplied by everything else here. So one thing that I can do is I can actually let w, you can use u or w, doesn't matter. I can let w equal x cubed plus 1, and then let dw be the derivative of that times dx. So the derivative of x cubed plus 1 is 3x squared, and then multiply that by dx. That's for the reason we talked about last time, that entire thing gets encoded as dw. And now I'm going to see if I can make the substitution and turn this entire integral here into an integral only in terms of w. Let's see if we can do it. So that's now going to be equal to the integral of dw over the square root of w. And we talked about in class the fact that that is the same as w to the minus 1/2, and we also talked about the power rule, which tells us that the antiderivative of that is w to the negative 1/2 plus 1, that's 1/2, over negative 1/2 plus 1 plus c. So that works out to 2 square root of w plus c, which I can then simplify, or rather rewrite in terms of x as, let's see, what was w in terms of x? See, this is the thing about the tablet, is that it's so easy to lose your work, but I can zoom out and see that w was equal to x cubed plus 1. Now if I'm taking an antiderivative of something in terms of x, I am almost always going to want an answer in terms of x. Now we'll talk later about what we do when we're calculating a definite integral using substitution. There are a couple of techniques for that. But that is the basic idea of the substitution strategy, is look in, and I think I have a laser pointer here. Isn't that cool? So I look in this integral here. I see if I can find some complicated expression which I would like to make simpler, but also find its derivative being multiplied by everything. Now that derivative has to be multiplied. If it's being divided or added or something, that doesn't really help us. It needs to be multiplied because that's what comes out of the chain rule. So I have this complicated expression here which I can write as a composition, and then I have that derivative of the inside function being multiplied. Anyway, so that is the idea of the substitution technique. In the next video, I will talk about how to deal with some more challenging scenarios.